in terms of your tests, what coverage you would get throughout the software lifecycle. So at the top, you have the very manual tests. So technically, you could go and click a button, click through an app just to make sure it works, but that's not very efficient and also costs a lot of money. So what software engineers do is they incorporate testing throughout the coding process. So at the very bottom of the pyramid, we have something called unit tests. Unit tests are focused on a function or method within a class, testing that it works. So it's the smallest part of your code. The reason it's at the bottom of the pyramid is because you can write many of them fairly quickly, fairly cheaply, and you can keep running them again and again in an automated way, saves on time. When you go up the pyramid, you can see we've got something called integration tests. You can see integration tests as a layer above unit tests in the sense that instead of testing each thing in isolation, you're testing that things knit together correctly, that each component can speak to another component. And then at the top, you've got your end-to-end testing. So this could be like a smoke test on the UI, doing a click-through test. The reason that we've got this pyramid is because integration tests and end-to-end tests are a bit more expensive to run, they take longer to run, and so we tend to only cover the key flows of the application for these tests. But today we're just going to focus on unit tests because this is such a big topic, so we're not going to cover all the pyramid today. So what is the purpose of unit testing then? I think unit tests are your friend. I don't claim don't worry about this. I just took it online, so don't share this around. But they are your friend, and you can easily write and run loads of them. And when you do, it goes well. If you don't write any tests at all, it can be a nightmare because they can do unexpected things, and your app you can't really trust what you're building essentially if you don't have a test there. So what is a unit test then? So now that we know what they're used to do, we can think of its structure. I know Prasheen's sad, I know we've got a range actors there. So the way that a unit test is structured is you set up the things you need to test, you act on it, so you run your production code that you want to test, and assert is you're comparing actual versus expected result. Ooh. And inside all programming languages, but for Ruby, we've got the RSpec unit testing framework, which contains neat methods that you can reuse to write your tests in a simple way. So I'm going to show you in a second what this means, what we've got described. So your system under test, or SUT, is the thing that you're trying to test within your application. So it's a class or module. Context is a scenario or conditions that you're running your tests in. And then your it is usually your assertion, so expected versus actual result. So before further ado, let's have a quick look at some code then. So I've got like a simple repo set up. I've got a spec file, and this was what I mentioned before. Is that too small? Should I zoom in a bit? I can zoom in. There you go. Much better. So this is my describe block. So that's describing the system under test that I mentioned before. So my system under test here is called bubble tea time, because that is the class that I'm trying to test, which is within my live folder. And if we look inside that, I've just got an empty class called bubble tea time. So usually when we start testing, it's just good to just run RSpec, which is the command to run the test. And at the moment, I've got no test cases in there, so that's why it's 0. So that's a good place to start. All right, so let's set up one thing that this bubble tea time class can do. So let's say it can sum 3 numbers together. All right, so I can use this let, and what let does, but bubble tea time, what this does is it just sets up a nice reusable sort of name that I can reuse in my test. And I can do something fancy, which is describe new. And what this does is it will run the block of code. So the describe class bubble t time.new, create a new instance of that class and assign it against this reusable variable that I can use. Great. So I can have another describe block. Now that I've described what I'm trying to test, I can describe, say, a method that that class has. So say it has a sum method. I can use this describe block to wrap my tests in, because essentially what you want to do is within your test, you want to make it read like documentation. So if someone is new to the project and hasn't seen that code before, they can go to your project and be able to lift off the test code and be able to read through what your class is intending to do. So here I'm saying that this method sum will return the sum of 3 numbers. And what I can do there is I can use my methods that I have from RSpec, and I can reuse this for t time, and I can call sum, put in 3 numbers, and I'm expecting that to equal, let's check my math, 6. Oh, 6, there you go. So this is my assertion that I mentioned before, testing your actual versus expected result. And then this is the describe block that describes what I'm trying to test. So here it's the method, and up here for the whole file, I'm testing the bubble t time class. So if I run this, it's not implemented yet. So what I can do is I can go and implement the method within that class. So I can sum 3 numbers together, and then we shall see the test pass. All right, so if I run it again, you can see it's passing now. Great. So that's the general structure: range, act, and assert. So here I've got act and assert in one line. So that's the general structure of a unit test, but how do we want a unit test to behave? The first thing is, when you're trying to test something, it's good to think about the scope of what you're testing for. So what is it that you're trying to test? Number of times that I've seen tests written in a weird way, it can get quite painful if you don't think about these things, such as making your test deterministic. So what do I mean by that? Every time you run your test in the same conditions, initial starting conditions, you should get the same result every time. So there's no sort of weird randomness involved, because if you have that, you might get false positive results or false negative results. Test sampling is important because you want to be able to test the right number of values. So for example, if I wanted to run like a survey across the US and I wanted to check the number of restaurants in specific states in the US, I wouldn't just pick one data point from one state. I would pick it from and sample it from many, many states. And you need to make sure they're well isolated and fast as well. So well isolated means that each one of these describe and it blocks can be run by themselves without dependency on other tests. Because if you start to make tests dependent on one another, then you will find tests failing randomly, and we don't want that to happen. So let's make an example then. So I'm not going to do test first for this one because I want to demonstrate how it might look if someone doesn't do the test first. So let's say I have a time for method that returns a certain value for a specific time of day that I run the code. So let's say I've got let's say I do time now, try to code on the fly, Ruby, which is not my first language, so just bear with me. So let's say I format it into hours and minutes. Okay, so nervous now. So I'm just going to introduce this lunchtime constant because it just makes it look nicer. So let's say lunchtime is 12 o'clock as the string, and let's freeze that down because it's a constant. So when it's lunchtime, I want it to return it's time for lunch. Okay, so let's say when dinner time, time for dinner, whatever time you eat dinner, else, let's say the default case is bubble tea time. Okay, cool. So we've got some code there. All right. So the trouble with this is because this piece of code is running the time that the user is running this code, there's some issues when it comes to testing, right? I'll do an example. So let's say we describe time for method that we've just introduced. Okay, so let's say it returns a message for lunchtime. Massage, I don't want that. Message for lunchtime. And then if I try and expect that the bubble tea time dot bubble tea time, and then if I call time for to equal time for lunch. Oh, what mouthful. So if I run this test, what's going to happen is I'm expecting it to fail. Oh yeah, I didn't initialize a constant. So let's initialize that. That was a bug. So let's say dinner time is 6 p.m. Oh, let's rerun that test. You can see hopping between the test and the code is quite helpful. All right, so you can see, oh no, I've got bubble tea time instead of time for lunch. This is the scenario of the test being non-deterministic. I'm trying to run the test, but it's failing randomly just because it happens to be at 17:23 where I am running this piece of code. So to make the test deterministic and testable and give your same result every time, you need to be able to control the random elements of your code. In this case, we need to be able to control time because we know that the time could change. So for this scenario, flaky tests. We don't want flaky tests. We want to control the test down. So we need to control time. So a good way to do that is to use something called time cop. But if you're doing Rails, there's probably what the Rails time freeze thing that's built in. I just forgot the name of it. So let's say make a new time for this test. Let's give it the 20th of September. I'm going to pretend that for this test, I'm running it at 12 noon. Brilliant. And then I can make a block for that and put this assertion, so put the code that I'm trying to run and test inside that block. And what that would do is it would run it on the condition that the time will always be 12 noon. So if I run the test now, we can see it passing. So you can run it again and again and it will pass. All right. So why did I want to show that? I wanted to show that because the number of times that I've seen in repositories where there's flaky tests, which means that it's sometimes failing, sometimes passing, it's worth looking into and just making sure you know what you're testing, that it's well isolated and it can be run many, many times and still yield the same result. And what I just did then only touches upon this topic. I don't have time to discuss test doubles in detail. It will probably be a nice sort of future talk. But in that sense, what I'm trying to do is I'm trying to stub So control or hard code the response of time. So instead of using the real time, I'm substituting the time object for a different time object in my test. And I really like this quote from Gerald Ross. I can't pronounce the name, but it's like a stunt double in a movie. Whenever you're trying to work with dependencies inside your test, it's good to think about substituting those dependencies for pretend objects so you can have more control around your test and your different scenarios. All right. So all I wanted to say is unit tests are your friend. Please, try and consider using them and learning how to test, because it really helps make you understand what you're trying to code. So what the criteria is, what's your actual and expected result. And it also helps another developer because you're essentially writing the documentation of your code by writing your test code. So for my example, I'm new to Ruby, but because I've done testing before in C#, I was able to pick up repositories just by looking at the test first. And that's been really helpful for me for my learning. Yeah, I'd like to say thank you. That was a really, really quick tour of unit testing, but I hope you found something useful there. So yeah, that's it. You can follow me on Twitter if you like, but I'll probably be just rambling about random stuff with C# and Ruby while I learn the language. All right, I'm gonna stop presenting, and if you have any questions, yeah, let me know. You can see there's some comments in there like time and date logic, always great candidates to introduce flaky tests, random. So yeah, anything to do with randomness, time, and date, you have to be quite careful when you go around testing. And yeah, live coding is scary, but really appreciate all of the support in the chat. Yeah.